Okay, so in this lecture we will discuss comparison test and limit comparison test. Okay, so the first test is comparison test. So comparison test is let the sigma k equal to 1 to infinity ak and sigma k equal to 1 to infinity bk be series with non-negative terms, and suppose that a1 less than or equal to b1, a2 less than or equal to b2, a3 less than or equal to b3, etc. ak less than or equal to bk. Okay, so that means each term in series AK is less than or equal to each of the terms in series BK. Okay, so that means the bigger series is BK. So what is a bigger series? This is. Okay. Now the test tells us. Okay, test tells us if the bigger series sigma bk converges, that means bigger series has a finite limit, that means converges, then the smaller series also converges. That means the bigger series converges, then smaller series converges. Second one, if smaller series diverges, then the bigger series also diverges. So this is comparison test. So if you have two series, sigma ak and sigma bk, be series with non-negative terms, and suppose that sigma b is ak is always less than or equal to bk. If this bigger series sigma bk converges, then the smaller series sigma ak also converges. Uh, if the smaller series sigma ak diverges, then the bigger series sigma bk converges. So now we will go through an example. Use comparison test to determine whether the following series is convergent or divergent. Okay. So given series is sigma k equal to 1 to infinity 1 by root k minus 1 by 2. Can you guess is this series is convergent or divergent? Guess, is the series sigma k equal to 1 to infinity 1 by root k minus 1 by 2 convergent or divergent? Give me a guess. Anybody? Anybody? Just guess it. Is it convergent or divergent? No answer. Okay, so I'm guessing that this is divergent because like 1 by root k, we know that divergent, right? Sigma k equal to 1 to infinity 1 by root k diverges by p series test. So here, if I take ak is equal to 1 by root k minus 1 by 2, and I'm taking bk is equal to 1 by root k, then what you can tell about 1 by root k minus 1 by 2 is greater than or equal to 1 by root k for all k, right? Why? 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 We have root k minus 1 by 2 is always less than or equal to root k, then which implies its reciprocal is always greater than or equal to 1 by root k. So what you can tell about we have sigma 1 by root k. The bigger series, is it convergent or divergent? sorry, smaller series. This is smaller, right? Is what you can tell about this series? Is this series is convergent or divergent? Then this series 1 by root k
Divergent.
divergent, because here what do you mean by 1 by root k? 1 by root k is all is 1 by k raised to 1 by 2, right? So here p is equal to 1 by 2, which is less than 1, therefore this is divergent by p series test. So the smaller, so the bigger series, sorry, smaller series divergent. Then what you can tell about the bigger series? Therefore, sigma k equal to 1 to infinity 1 by root k minus 1 by 2. Is it divergent or convergent? If bigger series divergent, sorry, smaller series divergent, then the bigger series also divergent. Have we got it? Now tell me what about second question. Sigma k equal to 1 to infinity 1 by 2k square plus k. Is it a convergent or divergent? Can you guess? Okay, I am taking ak is equal to 1 by 2k square plus k. 1 by 2k square plus k. And what you can take bk? This
1 by 2.
1 by 2k square, right?
1.
1 by 2k square. So why? Because 1 by 2k square plus k is always greater than or equal to 2k square. Therefore, 1 by 2k square plus k is always less than or equal to 1 by 2 square. Therefore, here ak is always less than or equal to bk for all k. And what about this bk? Sigma bk is equal to sigma 1 by 2k square. Is it convergent or divergent?
Con- con-
Convergent, right? Okay, convergent by p series test. Because this is okay. This is actually sigma 1 by 2 times k equal to 1 by k square. So this is convergent. So the bigger series converges, right? Then what you can tell about smaller series? If bigger series converges, therefore
also convert.
smaller series also converge. Okay? By comparison test. Smaller series also converge. So have you got it? So what is a comparison test? Comparison test is sigma k equal to 1 to infinity ak and sigma k equal to 1 to infinity bk, b series with non-negative terms, and suppose that if bigger series converges, then smaller series converges. If a smaller series diverges, then bigger series diverges. So this is the first test, the comparison test. Now we will move to the second test. So today we will study only two tests. Second test is a limit comparison test. Okay. Limit comparison test. So theorem, the limit comparison test. if sigma ak and sigma bk be series with the positive terms, and suppose that rho equal to limit k tends to infinity ak by bk, rho equal to limit k tends to infinity the akth terms divided by bkth. So the first condition is if rho, this limit, is finite and greater than 0, then both series converge or diverge. That means if both series, if this limit is finite, then both series converge or diverge simultaneously. Now second, if this limit rho is equal to 0, then if bk converges, then sigma ak converges. That means if rho is equal to 0, that is limit equal to 0, sigma bk converges, then sigma ak converges. And third one, if rho is equal to infinity, rho is equal to infinity, sigma bk diverges, then sigma ak diverges. Sigma bk diverges, then sigma ak diverges. So this is the limit comparison test. So what we have to do is we have to take a limit ak by bk. If that limit rho is equal to is finite, then both converge or diverge simultaneously. Rho equal to 0, then bk converges, then sigma ak converges. Rho equal to plus infinity, then sigma bk diverges, then sigma ak diverges. So now we will use we will do few examples. Limit comparison test whether the following series converge or diverge. Okay. So first question, sigma k equal to 1 to infinity root k plus 1. So this already we shown that such a sequence series diverges, right? So now I'm taking the ak is equal to root 1 by root k plus 1. So now this bk we can guess anything. So by looking at the series, given series, we can choose bk. So I'm okay. Tell me, anybody have any doubt? Bk is equal to 1 by root k. Okay. Now I'm taking rho. Rho is equal to limit k tends to infinity ak by bk, which is equal to limit, which is equal to limit k tends to infinity ak by bk, which is equal to limit k tends to infinity ak. Ak is 1 by root k plus 1 divided by 1 by root k, which is equal to limit k tends to infinity 1 by root k plus 1 into root k by 1. So if you take k outside, limit k tends to infinity root k into 1 divided by root k into 1 plus 1 by root k. So that is equal to this. If I put a limit k tends to infinity, the rho, that means our limit is 1. So rho is finite and positive. So rho is finite, then we know that both series converge or diverge simultaneously. So here we already know that this series, what about this series, sigma k equal to 1 to infinity 1 by root k, this diverges, right? So if this rho is finite, both converge or diverge simultaneously. So what you can tell about this series? This series diverge. Now any doubt, any doubt? Now we can do this from sigma k equal to 1 to infinity 1 by 2 k square plus k. So here likely to behave the convergence series. To prove that the given series converges, we will apply the limit comparison test. So I'm taking AK equal to 1 by 2 raised to 2k square plus k, and I know what about bk. So here bk is equal to 1 by 2k square. So we can choose 1 by 2k square or 1 by k square, anything. So that we will choose bk in such a way that we will get a finite limit, right? So if you know this, you have a guess that this is converged. So rho is equal to ak limit k tends to infinity ak by bk, which is equal to limit k tends to infinity 2k square divided by 2k square plus k is equal to limit k tends to infinity 2 divided by 2 plus 1 by k, which is equal to 1. So this limit is finite, therefore both the series converge or diverge simultaneously. And we know that this series, hello, പറഞ്ഞോളൂ, ലെഫ്റ്റ് ലെഫ്റ്റ് ആയോ? ഓക്കെ ഓക്കെ ഓക്കെ, I will say.